So where is everybody?
Probably sleeping. Yeah.
You think they're sleeping? Well,
It is Monday.
Kyle is online. Kyle posted a comment before I went live. That's dedication right there. Or maybe he's got a bot. Could be a bot.
It's probably just too cold. It's like like 9 people.
So, yeah, it only shows 5 on my screen, but I believe you. So the Worcester Public Schools often calls the day before to let us know that they're going to cancel school. I get it, because people need to plan, and sometimes, they're so chicken that they decide in advance to cancel school. I mean, the first time they canceled this year was because it was going to be cold the next morning. And because of COVID, the buses have to have the windows open. And they were afraid that the poor little boys and girls would freeze their little noses off. And I'm like, just wear an extra mask. But anyways, so last night I get the caller ID and it's Worcester Public Schools. And I'm like, damn it, there's no reason to cancel school tomorrow. It stopped snowing yesterday. And it was the superintendent of schools letting us know that she was not canceling schools. She said, we will not cancel school. We will not have a delay. We will start on time. Have a happy day. I was like, wow. I guess I'm glad that I still get those calls. I really can't wait till my kids stop going to that school, because they call like 5 times a day. And I have them on the list of like 20 people that can call me, and it always goes through. Because I figure if it's during the day and one of my kids are at school and they need to call me, they probably need to call me. But it's never that. It's always, and remember, it's time to register for kindergarten. Well, I don't need to register for kindergarten. Well, maybe I do. Actually, kindergarten would be fun. Who would do kindergarten again if they could? Who would want to be a kindergarten teacher? Not so many volunteers. All right. Let's see what we got here. I'm going to turn some lights on so we can see. And so if you are, so it just did that, right?
Yeah.
The first time that happened, I wasn't sure if I was just having like a low blood sugar moment or low blood pressure or something. I was like, am I blacking out? Do I need to hold something? That is weird. I have bulbs at home that are programmable, and so you can actually set it to do like the circadian rhythm. So in the morning and during the day, it's a brighter light, and in the evening, it's a more reddish light, which is actually good for your brain. It helps you go to sleep easier. But they do that when you turn them on. They don't know what they're supposed to do, so they start bright, and then they switch to whatever it is. I wonder if that's fancy bulbs here in the classroom. All right. So today, we're gonna break out at about 20 after or so into some group activity. Is there a representative from group 1 here? No. How about group 2? Group 2, we got represented 3. Group 1. It's gonna be group 3. Group 4. Group 4 is well accounted for. Group 5. Anybody here? Group 5. All right, so here's the deal. And this is going to happen on a lot of the Mondays. I mean, all like 3 or 4 that we have left anyway. Is that we're going to do some group activity during the class. I had wanted to do this in all the classes, but I talk too much sometimes. So if you're not physically with your group, figure out how to do it with texting or Slack or something else like that, right? I think you guys can work that out. It's 2022. We've all been using cell phones for a long time. So see if you can get in contact with your group while I'm doing this introduction here, but also pay attention. But if I see you flipping with your phone, I'll know that it's not because you're like shooting a thing because my fly's undone, because I just checked and my fly is zipped up. So that's not why you're flipping around on your phone. That is the question of everybody that's in front of the room when somebody in the back of the room starts giggling, is did I forget to zip up my fly? So, all right. Automating CNC programming. That's the topic, right? Anybody want to venture? What does that mean? I mean, CNC already means computer controlled, right? 1. Oh, 2. There's 3. Okay. CNC is computer numeric control. Does control have an E at the end? No? Good. I didn't put one. Computer numeric control. So computer already sort of implies some sort of automation, right? The computer has replaced the Etch-a-Sketch hand cranks. So it already implies some sort of automation. So when we say automate CNC programming, what do we mean? If we say automate CNC programming, what do we mean? And since this is our class, we actually get to decide what we mean. So that's pretty cool. So nobody has to tell it. We don't have to believe somebody else's definition of it for the purpose of the class. We get to decide what it means, and that means we get to decide then what we learn about what we do about it. So what do we mean? We say automate CNC programming. I just did. Right?
Yeah, that's good.
Is that what the question was?
Yeah.
Yeah, I thought of that too. But now there's like glare. Is there controls for the shades? Press here to be. No, I don't want to do that though. Room control. And I have to wait. No. Oh, it's not automatic? I didn't need to do that anyway then. Mute. That's not really that much better, but thank you. I'll try to angle it, move the glare somewhere else. I'll try not to write anything real important on the whiteboard. That's muted, right? Yeah. So what do we mean? What do we mean when we say automate CNC programming? All right, so I guess programming is the creation of the information that goes to the machine tool that controls the machine tool, right? So the programming is the creation of the toolpath, basically, right? All right, so if we say automation of CNC programming, then what do we mean? Yep.
Automating the toolpath generation.
So automating the toolpath. So in your mind, if you say, let's say you've got a startup idea, you're pitching your startup idea to your investors, and your startup idea is to automate CNC programming. What do you tell me that your product does?
My product would probably take it apart, analyze it, and then try to.
So take apart?
Yeah.
Okay.
Try to generate the most optimal tool path and use of tools to get it done in the least amount of process.
I'm setting up so there's like a second microphone so you can talk and check it out. Talking to the microphone. So you're gonna take apart.
So I would take my product would take
Okay,
a
in the
part.
camera.
Hello. My my product would take apart and then attempt to create the most optimal tool path and use of tools to be able to make the part in the least amount of processes.
All right, I think I got you. I got you. So you're going to take the part. Somebody's going to trip on that and fall down the stairs now. So take apart, say it again.
Take apart, generate the best tool path and use of tools. By best, I mean most efficient. That needs further defining.
Take apart, generate the best, most efficient tool path and use of tools. Okay. So I have a part. That's not what you meant.
No.
Right? So you guys all know that's not what he meant, right? He didn't say take apart, like I got a part in my back pocket, I'm going to take it out. Who's the guy that dances with wolves? Mel Gibson. Is he the guy that dances with wolves? I'm dances with chairs. All right. So we're not going to take the part out of our pocket, right? So what did he mean when he said take apart somebody? Because you guys know what he meant.
Piece of stock.
Okay, so we're going to take a piece of stock. I didn't bring a piece of stock with me.
Oh, well, that's unfortunate.
Is that what he meant? Did he mean take the piece of stock and generate the best tool path and use of tools? You're shaking your head no?
Yeah.
What did he mean?
Some form of CAD file or CAD model.
So the part isn't the thing that you have in your pocket, right? The part that he's talking about, and you already knew this, you just didn't articulate it that way. I'm being, what's the word? You asshole. Any one of those things works, right? So you want the representation of the part. So you're going to take a representation of the part. So you're going to take a representation. We got a verb. That's cool. You're going to take a representation. Verbs do actions, right? So verbs sort of define the things we do. It takes a representation of a part, and it generates the best tool path. I'm going to stay with best. I know you clarified it efficient. The best tool path and use of tools. What makes it the best? Yeah. Oh, wait. It's kind of expensive. I'm not going to throw it that far.
Would the best be highest quality while also maintaining speed and like efficiency?
So the highest quality while maintaining speed and efficiency, right? Who's ever bought flowers to give them to somebody? Most of us have bought flowers to give them to somebody, right? Who's ever bought something to give it to somebody? Okay, perfect. So most of us have bought something. So those of us that have bought flowers to give it to somebody, so raise your hand if you're the kind of person that goes to the display of flowers and searches for the best bouquet to give to the person. You are? What's the best one in reality? The cheapest? Okay, so you're looking, you're sort of the discount florist. Okay. What's the best one?
I would say
The ones that aren't wilting. So inexpensive, not dead. I mean, I guess they're all dead once we cut them, right? Not visibly dead. Inexpensive, not visibly dead. Roughly the same. Okay. So for me, the best is the first one I come across that's in my price range and doesn't look dead. That's the best one for me. Because for me, but my wife, for example, she would look at each individual flower and say, no, not that one. She picks out green beans that way too at the grocery store. She like picks out the green bean and puts it in the bag. Nope, not that one. So some different people have different idea of the best. So I don't like the best here. It's not necessarily even the most efficient, although that seems like a good way to judge. But efficient could have different meanings too, right? Efficiency of money, efficiency of material, efficiency of time. So efficient could mean different things to different people too. How about we generate an effective? We generate a tool path that will make the part to within our needs, right? Because there's a lot of different things that go into what the tool path will create for a finished part, right? So is it within tolerance? In tolerance is about the location of the features, the size of the features, the surface roughness of the features, all those different things load up in the tolerances. So an effective toolpath is a toolpath that creates the part that we need with minimal fuss. Like minimal problems, I mean, right? Okay. All right, so generate an effective toolpath. And so you meant the best use of tools, but do we care if we've got an effective toolpath? Right? An effective toolpath will be one that uses tools that are reasonable for us to use. Right? So I'm trying to make it as simple as possible. This is the term I usually use. If you've seen me teach M1800 or even Professor Brown teach M1800, we call the art the drawings and the solid models and the things that represent the design. We call that the art. And so we take art, generate an effective toolpath that will give us a part. It really doesn't, does it? We don't go from art to effective toolpath to part directly. There's a step we missed, right? We're going to need a machine to execute the path. We're going to need somebody to set up the machine. We're going to need somehow for the stock material to get into the machine. We're going to need somehow for the part to get out of the machine, right? So we're going to need all those things also to go from art to part. But we're talking about automating CNC programming. And so to automate CNC programming, we're going to take art. We're going to take some representation of the part. And we're going to generate an effective toolpath that creates the part. I'm running a little bit late, but I think that's okay. What the hell with the most efficient or the best, okay? What's the minimum viable product? What's the minimum thing we need in a toolpath? Because if we don't know that, we can't make the best one. So our automation is This is something I often ask classes when we talk about automation. I'll probably say it again later in the term. From management's perspective, what's the difference between automation and outsourcing? There is a difference, but from management's perspective, what's the difference between automation and outsourcing? You need to call out the comments more.
The same stuff that you said here.
Okay, but call out so I know that people are interacting. It makes me feel good. What's the difference? What was the question? Yeah.
One's on-site, one's not.
Oh yeah, the difference between automation and outsourcing. Yeah, maybe. I don't think that's the difference.
Chat from Kyle, how much HR goes into outsourcing?
Hopefully none, unless you're having to do HR training of the people that go talk to the people you're outsourcing to, right? Who's seen the movie Office Space? Really? Oh, that's gonna have to be a homework assignment. Like it's online commenting people who's seen the movie Office Space. Wow.
I have like a 5-second lag on that, but
Wow. You guys haven't seen the movie. That's amazing to me. But okay, I won't do the Office Space joke then. Because it'll be lost on. It's about these guys that work at a high-tech company and they have cubicles. And they work from their cubicles. And one of them rebels. And he's the one that ends up getting promoted. I'll just let you know. While everybody else gets laid off. But it's better than that because there's millions of dollars that they steal from the company. There's all kinds of cool stuff that goes on. Don't worry, I didn't give that much away because it doesn't go down the way you think it will. All right. So anyways, the character in Office Space that he talks to the customers so the engineers don't have to. And there's a funny line there. I'll let you watch the movie to find the funny line. So it's not really about the HR though. It's really more about the capital investment. So to automate a process, we have to invest lots of money, typically. And to outsource a process, we just have to make a few phone calls. So, but we have a lot more control in the automated process and things like that. We'll talk about this as we get to general factory automation more. But if we're going, so you could think of it though as being the person that it gets outsourced to, or you could think of it as the steps to automate, because it's really about the same thing as a mental exercise. What do we have to do to generate a toolpath? Let's forget about the effective toolpath. What do we have to do to generate a toolpath? What are the steps that we have to do to generate a toolpath? And with that, I want to break out into the group activity. Has everybody made contact with your group? So if everybody's made contact with the group, which were the groups that are not here? There's group 5. Anybody from group 5 here? Oh, you guys are here. Okay. Is there anybody from group 1 that showed up? Okay. Group 1. Can you find out if there's anybody from group 1 online live? Which part should we give to group 1? Should we give them the easiest part or the hardest part? I think we're gonna have to give them the easiest part because they're only gonna get to look at it on the camera view. It kind of sucks, but I think we have to give them the easiest part. So the easiest part's going to be one of the 2 lathe parts, right? I'm going to give them this part because this one has dimensions and tolerances that this one doesn't have. This one just has shape. So I'm going to give them this part. Everybody know what this part is? If you don't know, this one's defective. Oh, come on. All right. Yeah, I want to hit it hard because I don't want it to try to stop on this side because it's got a little bump on it. But anyway, these things, if you make them right and you tap it, it flips over and then stands back up again. Then if you tap it the other way, it flips over and stands back up again. We made these in M1800 for about a year. We've stopped making them. But when I first discovered the design and played with it, it was during COVID, so we had to do all our meetings on Zoom. And I used to sit at my desk with the Zoom going and just play with this thing back and forth when I was on Zoom meetings, which if I forgot to mute the microphone was really annoying to the people at the other end because the microphone was just above the table that this was going thunk, 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 thunk on. But anyways, I'm going to put this down. I'm going to focus the camera on it. Maybe. I'm going to put it down over here and focus the camera on it. So group 1, that's your part. This thing, not the computer monitor. And I'm going to go here. Sweet. So they see what their part is then. I made their part smaller so we could see the schedule too. Maybe not that small. There. Yeah. There, I'm gonna go with that one. Any other groups really crave a lathe part? Nope. Okay. Where's group 5? Here's your part. Group 2. There's your part. What's the next group? 1, 1, 3. Group 3. I could see that like popping out of your hand and either crashing the computer or the phone. And the group that doesn't have a part yet. All right. So what I would like you to do in the next, what's the schedule say? We'll go to 9:50. So in the next 20 minutes, I would like you to write down the steps that you need to do to take a representation of this part and turn it into a toolpath. Because to automate something, to automate steps, we have to know what the steps are. What's his name? Oh, so you guys can like group up if you're not already grouped up. Like sit with your group, talk with your group, figure it out. If you need to do a little Zoom with your group or whatever, do that. But with your group, list these steps that you need to do if you have a representation of this part in order to make it into a toolpath that could create that part. Yeah, you get the hardest part. Sorry.
Features on every side.
There are features on every side. I will note that, and you guys with the flat platey part there, ignore the broken tap. That's not a feature in the part. That's the reason that that particular instance of the part was on my bookshelf. All right, so that's good. While you guys are doing that, I'm going to mute my microphone. Somebody, when we get back to the class discussion thing, remind me to unmute. And I think I unmuted. All right. Which group are you guys? Group 5. Group 5. Why don't you guys, one or both of you, one or two of you, come on up here and bring your part with you. You can bring your list with you too. Perfect. All right, and try not to die. All right. So describe, here, one of you take this. There you go. Describe the steps that you need to take, and feel free to write on the board or whatever if you need to. But what are the, or you know what, you guys talk, I will write on the board.
Okay. So to make this part here, can you see it? Yeah. We were thinking that we should start by facing off what's currently the top of the part. And then our next step was to make the 2 pockets, one of which goes all the way through, and one of which doesn't. And then we think the next steps are to drill the counter bore, the 2 counter bores that are there. And then drill the, I believe, 4 through holes. And then contour the edges. And then we said flip the part. And face the top all the way down to make the extruding boss. And then, I don't know the term, but putting the ridges around the top of the boss. Or is that a mistake?
No, that's fine. Texture.
Yeah, sure, we can call it that.
Texture, the fillet.
Yes, yeah.
Here, let's hold that up to the camera so the camera can see what you're talking about. So if you look at the fillet on the top of the boss, you can see that there's some texture along it.
And I think that was yeah.
All right, that's good. You guys can sit down. And that was group 5?
Yes.
Group 5. The which was the group that had the turn part? You guys, do you guys want to come up and represent? Somebody can grab the microphone and somebody can like do the demonstration. I like it.
So we said import our model into CAM software. Determine our stock dimensions. Set our work coordinate system. And then we said first we face it. And then we turn the rough OD followed by a finished OD on one of the threaded ends and the larger diameter. And then we said cut the threads on the end that's facing out of the spindle, then center drill, and then third drill, and then part off, and either flip the part and turn that other diameter, or if the machine has a sub spindle, like exchange the part, turn the thread.
All right, did I get everything here? Import the model, determine the stock, set work 0, face the part, rough the OD, cut the threads, center drill, drill, flip, turn, and thread.
Just a finish pass.
Yeah, and then in between this rough, there's a finish. Okay. Okay, perfect. Group that had the hard part. Go ahead, grab this.
All right.
Demonstrate your part and tell us the steps.
Okay, so we have this part. Its overall shape is like this. It has 2 pockets on either side, same location. 4 tapped holes that are perpendicular to the line. 2 holes on this side, 1 hole on this side. Both are tapped, and then we've got these 2 small holes on either side as well. So what we thought to do, or one of the ways, there's multiple ways, but we thought this was the probably most efficient, is so think about your stock as if it's like this. If you have a square that is, if you start with a square, you're going to face off this top edge and tap these holes. So you've still got a block that's not exactly in this shape yet. Then you want to take your part, put it like this in the mill. So it's actually sort of like this, with this side being perpendicular to the wall of the mill. And then you want to perform a kind of a contouring operation outside, on the outside here. Then you can flip it in, or I guess technically first you would also do the pocketing operation and this drilling and tapping operation. Then you could flip it in the mill vise and then contour the rest of it out such that you have this finalized shape. And then you would do the same, pocketing, drill, tap operation here. You'd also do this chamfer on this edge. And then all that would be left would be to fixture it like this, drill and tap, and countersink these holes, and then fixture it like this and drill and tap this hole.
All right. Is there another group that's in the room? Go ahead.
Can I just leave this here?
Yeah, it's fine. You guys will notice I stopped writing down everything everybody was saying. There's a reason for that. I'll go into that in a second.
Okay, so this was our part. It's like a big plate that's like equal thickness on either side. There's patterned holes on the top of it through the whole part. Some of them are tapped, some of them are not. They're all sorts of different shapes and sizes. I guess they're all circles. But step 1 was to put your art into digital form by making like a CAD model. We kind of assumed that this was the end result and not like our starting result. So from there, we wanted to generate our toolpath using software. And to do that, we had to select an overall stock material, which would determine our speeds and feeds, a lot of our tooling, as well as it would help us to designate an origin for our 3D or for our toolpath model. So our toolpath model, or for our toolpath we're going to do it in 2 fixturings. So the first fixture would just to be like to set it up in like a pair of like a regular vice grip, and to do all of the holes. Or well, we start with a facing operation, and then do all of the holes. And to do the holes, you start with a center drill. I think the drill mill in the shops, and mark the center point for all of the holes, and then come back through with the particular drill bits that you need for all of the holes. And then the last one would be to tap any holes that need to be tapped. And then after that, use the drill mill again to break all of your edges. So all of the interior edges on the circles and tapped holes, as well as the outside edge of the part. And then the second operation would be to flip it, and instead of fixturing it in a clamp, fixture it using some of the holes you drilled in the first operation. And that way you can do a cutting operation to get the outside geometry of our part, and then do the same thing and break all of the edges with a drill mill on that side of the part. Then remove the part.
Okay, perfect. All right, I'm not going to have group 1 go here because then we'd have to send them a link and they'd have to log in and do all that stuff. What's that? Oh, they sent you a list. Okay, perfect. Do the group 1 list.
Yep. So steps for automating would be know exactly what your stock material.
Wait a second.
I'll give their part. So.
There you go.
Know exactly what your stock material that you need. So some form of rod, the closest diameter of the part. Set up a program to have a stock within the lathe, and this will allow for multiple parts of one piece to be made out of one stock. Create tool paths, so facing, create the taper and then the cutoff. Have some form of conveyor to take away the parts, and then either robotic inserts. Either a robot inserts the stock into the lathe or a person does.
All right. What's similar about what everybody said? So for all of the operations, what did all of the groups focus on? For all the parts. So the thing I noticed that all the groups focused on for all the parts was thinking about exactly what the tool's going to do in the machine tool. So here you talked about doing a facing operation, making a pocketing operation, doing a contouring operation. And so you were thinking about creating the program, right? So you were thinking about what the program would look like. Similarly with the flat plate, you guys went into detail about breaking the edges on the holes and everything like that. That was really good. And likewise, you guys I think I still have yours, right? So import the model, determine the stock. I was getting really hopeful you had the key when you guys got to your third step here. I was hoping you guys had knocked this assignment out of the park when you got to your third step here. Because import the model, right? So if we're automating the programming, so you guys, what all the groups seem to do, and this is the first time I've ever done this exercise, so I had no idea what was going to happen. But I think you all seem to do the same thing that I would have intuitively done the first time through too, is start thinking about the part in my hand. But the question was, what steps would you have to do to automate the programming of this, right? Did I ask the question wrong, maybe? That was the question I meant to ask. So I probably said, think about how to make the part. But what I really want to know, so to automate the programming, you have to have a way to get the representation of the part into your automation system. Your automation system is probably going to be some sort of macro that runs in your CAM software, whether it's an internal thing that you've automated, or, you know, I've automated creating toolpaths using Excel. So, I mean, a CNC machine tool really only does three things. I mean, four things, I suppose, right? It spins the spindle. So you can turn the spindle on and off. That's one of the things it does. We'll forget about the fact that you can change tools and all that stuff because you don't have to do that for it to be a CNC machine. So it spins the spindle. It moves the tool relative to the workpiece in a straight line at a known speed, right? It makes a linear feed. It moves the tool in relation to the workpiece on an arc with a known speed, and that could be counterclockwise or clockwise, doesn't matter, but it's a known speed through a known path. And it moves in a rapid motion, which moves as fast as it can from one spot to another spot inside the machine tools envelope. Those are the only things that the machine can do. And so if you know what your part needs to look like, and you know that the command for a straight line is G01, the command for an arc is G02 or G03, depending if you want clockwise or counterclockwise, and the command for rapid is G00, if you know those commands, then if you're making a shape that you could determine with mathematical geometry, you could create the algorithm that makes the point-to-point geometries, the point-to-point motions, right? So I've done this before using Excel. I've done it with copy and paste in Microsoft Word. I don't recommend copy and paste in Microsoft Word, but it was the tool I had on hand at the moment. I've done it on my cell phone, sitting in an amusement park with it was Google Sheets because I didn't have Excel on my cell phone, but copy and paste in Google Sheets to create the code. Then I emailed it to somebody that was standing in front of the machine, and then they ran the program. I took a program that was created and I modified it, but whatever. So I loved it when you guys said, import the model, determine the stock, right? So what's the software going to do to determine the stock? It's basically going to say, is the stock axisymmetric, or like, is the part axisymmetric, or is the part prismatic? So it's kind of the first thing you have to automate. And you could do this at the outsource level, where it's the person who's dragging and dropping, right? So you could have some information at the level of, I'm the engineer who's operating this. If I know the flat platey part thing, there you go. So when we were working on code to automate stuff like this, we knew that if we had a part that was sort of two-dimensional, it has thickness, so it's three-dimensional, but it's really a two-dimensional part, right? It's got shape and it's got a constant thickness throughout it. We called that a plate part when we were automating stuff like this. And so if I had a plate part, I could drag and drop it onto the little icon for automating programming plate parts. So I take the solid model, drag and drop it onto there. And then that algorithm, the program itself, it already knew that it was a plate part. So if I took the model for this part and dragged and dropped it into that thing, it would fail to make effective code. I think it would have made code. It may have errored out. I don't know. But it would have failed to make. So how many times did you have to put this part in the machine? Group you guys.
I think that was 5 times.
You had to flip this part around. Automating the toolpath generation for this is non-trivial because you have to think about how many times does it get oriented in the machine. However, you could automate the toolpath generation for this if the operator selected the orientation and then dropped it in. And so you're only automating one orientation at a time, right? So you could simplify it. But in a plate part like this, it has to know what's the thickness. It has to know what's the box that defines the outside, and then what's the location of all the features, right? If it's just a two-dimensional part. And then we had to identify, so this feature has, this part has some clearance holes, and it has some tapped holes. So it has to, so to program for this part, to automate that programming, we have to import the model. We've got to get the representation into our automation system. We've got to then determine what stock material the part's going to come out of. Because we know we can't make a program if we don't know what the stock looks like, right? Because the program is about the toolpath that makes the stock look like the part. So we have to know what the stock looks like at some level. So import the model, determine the stock. You said next set the work 0. And so you could have an automation, you could have an algorithm that decides where the work 0 is going to be on any given part when you bring it in. Or you could always decide it's going to be top center of the workpiece material of the stock. So that's kind of a thing. It could be a rule. It could be an algorithm, but set the work 0. And then the next thing you guys all did in your head, but you didn't note that you were doing it. Maybe group 1 got it. I'm not certain from the way I got the list to me. But the next thing I want to do is identify the features. Right? So somehow we've got to use the computer, right? So this is where it gets to be a little bit tricky. So what are the features on this part? So we've got an outer boundary. That's a feature that we could identify. It's got radiuses on the corners. So that's a feature we'd identify. It's actually got chamfers all the way around on the top and the bottom. So that's a feature that we could identify, right? So we've got our solid model. In the solid model, we're going to be able to recognize the boundary because it's the space where there's no material outside the space. So that makes it easy that we can recognize the boundary. How would we recognize the fact that there's a chamfer on this edge? So if we're looking at a solid model sort of mathematically, how would we characterize the fact that there's a chamfer? So we're putting on our algorithm developer mode here. How do we know there's a chamfer if we're automating this recognition? So we know, right? Because we look at it and we see it, yeah?
I mean, it could just be like common practice to tell the macro that if it sees a hole to always break hole edges.
So we could build into our algorithm that we always break the edges. We could do that. I've had customer parts where they specify do not break the edges. They want a sharp edge. Those are the hardest ones to make, by the way. The ones where they say break the edges, those are the easy ones, especially if they don't tell you how much, because then you could really screw up and still make a good part. But how programmatically, if you have two faces that meet at some angle that's maybe greater than, I don't know, if you have two faces that meet at 90 degrees, that's easy to recognize mathematically, right? So you've got an equation for this plane, and you've got an equation for this plane. You can see where they intersect. It also makes it a line, makes an edge, right? So if you got two faces that meet like that, well, let's say if you've got two faces that meet and you see that it's a 45-degree angle, and then within a certain distance you see another face at a 45-degree angle, you could recognize that feature as a chamfer. So you could deduce it by knowing the math. I mean, it's simpler if you look at a profile of it, right? So if you just extracted it as a profile, We've got two faces that meet at 90 degrees. In our macro, we say break all sharp edges, so we're going to add a chamfer there. But if it's called out, we still need to recognize that there is a chamfer because we don't want to add a chamfer to that edge, right? Or unless we want to make it a fillet and we just keep running the thing over and over again until it's completely circular, until it's a completely circular sphere, right? So you could have the equation for this line, the equation for this line, where they intersect, and then you could add that chamfer in, or you could recognize the fact that the chamfer exists, right? So just recognizing the fact that there is a chamfer in the solid model, you've got to do work to identify the features on the part. Holes are pretty easy, right? And the center of the hole is pretty easy. And the diameter of the hole is pretty easy, right? Those are all things that we could intuitively see how to measure with software, right? Now, you guys don't have to be software programming wizards here in order to successfully do this, but this is the stuff that has to happen inside the code. It has to be able to do that. So we've got to identify the features. Once we've identified the features, what do we have to do? You guys did it intuitively. But what's this next step? Have you guys seen the Warner, the humanoid robot that's over in Washburn 108? So all seen that on a tour or something like that? No? Some yes, some no. So we got a 300-pound, 6-foot-tall robot that walks on its feet, swings a big arm. It's got this giant hand on one side. When he came here, I don't know why we anthropomorphize robots. I guess, well, because it's humanoid in shape. I guess that's part of the reason. And I guess because somebody decided to name him Warner. But hey, we shouldn't presume to know what the robot thinks and wants. Anyway. When Warner arrived here, there was no mechanism to stand, right? They had to figure out all of the code to control all of the actuators and sensors just so that he could stand before they programmed him to walk and then climb a ladder, drive a car, get out of the car, walk through a debris field, climb a ladder, open a door, cut a hole in a wall, and turn a valve. But to do all those steps, they had to first figure out, how do we stand? But he stands like this, sort of. I guess it's like a karate stance, huh? Ready to go. You guys have seen the YouTube videos with the robot where they knock him down with a hockey stick. Yeah, so Warner is their older brother. He was the first of these robots to ship out of that company. Anyway, you've got to identify the features. You've got to decide what the features are. Once we've picked the features, what do we have to do? So we've already got our stock material. We've figured out the stock material. We've set our work 0. We've identified the features. What's the next step in the progression that we have to do if we're automating this? Yeah? I think we're going to select the tooling. So what determines which tool we use? I'll give you a hint. A database that includes a list of available This could be a one-time thing where you make a list and you can use these tools. It could be an interactive thing that tells you which tools are currently installed in which machines on your shop floor. It could be there's a connection inside the CAM software we use is Spree. You can actually set it up so that when the software person, when the programmer selects a tool and applies a process to that tool, says we're going to use this tool to make this process, it automatically orders the tool from the vendor and has it shipped to your site. I recommend using that feature with care. We have it disabled here at WPI. But it's built into the software. The software has the capability of connecting directly to the manufacturer's website and ordering the tools for you. Right? That's an automation step. Getting the tool to the machine is an automation step that includes the procurement step. Right? So knowing which tool you need and ordering it. But anyway, you can have some list of tools from which you can choose. If there's because otherwise it's like there's an infinite number of shapes and sizes of tools, right? You would that's why when we at the very beginning we said we're going to find the best use of tools. Trying to find the best one is like trying to find the best rose at the florist by studying all of the petals and maybe getting the moisture content so you know which one is going to dry out the slowest, or maybe you want it to dry out sooner. Maybe that's best for you because you're going to like hang it up and put it in a dry flower arrangement. I don't know. Right? So define a list. Have a defined list. Pick a tool from the list that can possibly make the feature that's identified. You guys all did it in your head from knowing what we typically have around over there. I heard somebody was talking about it was probably a 3/8 end mill that made this and stuff like that, right? Because we often use 3/8 end mills in the WPI manufacturing labs. Do you know why? Anybody know why 3/8 is the end mill we push you to? Well, we buy them in volume, so they are pretty cheap. But that's not the reason we went with 3/8 for the number. When you're making an inside pocket, you know you have to have a radius, right? Because it can't. And so what radius do you pick? If you're doing this, that's going to be a pocket on the inside of your part, and you know you got to put a radius here. And you're in America, and let's say this is 1.5, and that's maybe 1.25. So some dimensions you're familiar with. What's the radius you're probably going to pick? You know it has to have a radius. Here's what I've observed. 0.25 or 0.5. That's what everybody picks because it comes to mind quickly. And if I used a 1/2 inch end mill and I wanted to make this 0.25 inch radius, is it possible? 1/2 inch diameter, 0.25 radius, yeah. It's physically possible. The end mill fits there, right? So first step in selecting the tooling, does it fit in the feature? Right? I think these holes are probably 0.26 inches, these clearance holes-ish, probably clearance for 1/4 So somewhere around 0.26 inches is this hole diameter. If I had a 1/2 inch drill, could I use that tool? No. Throw it away. Right? I'm going to pick a tool that fits in the hole. Right? So does it fit in the hole? Now, could I do it with an 1/8 inch end mill? Absolutely. I could go in and I could make a pocket that's the right diameter with my 1/8 inch end mill, as long as the tool's smaller. Getting back to why we do 3/8, if you use the 1/2 inch tool and you drive it into that 1/4 inch corner, at the moment it gets there, it stops and then it feeds in that direction. Momentarily, the tool stops and then feeds in the other direction. At that moment when it stops, it's no longer advancing forward and making a new chip. It's rubbing in the corner. for just an instant. Yeah. Anybody ever heard the tool when like it goes into the corner, it screeches, and then it comes out of the corner and it sounds good? And it screeches, and then it comes out of the corner and it sounds good? That's because they were doing this. So if the tool's smaller in diameter, there'll be a radius in the tool path here, and it will continue to feed around that corner, and it won't do that screechy noise, and it won't wear out the tool, and it won't leave a crappy surface finish inside that corner. That's why we drive you to use 3/8 tools. But pick a tool that fits and is capable of making the geometry. So somebody was talking about chamfers and talked about using the drill mill, or maybe you were talking about spot drilling and using the drill mill, right? So it's a tool from our list. It fits in the part, and it's got the right shape to make the geometry, right? So does it fit in the part? Is it the right shape to make the geometry, right? If we're tapping these other holes, it'd be hard to tap the holes with a cutting tool that doesn't have cutting edges that make threads, right? So you have to select the tooling from a list that's capable of making the part. Once you know the tools, what's the next thing you have to do? So over here in our determine stock, we've got to also know the material properties, right? So either when we drag and drop our file into our little macro thing, or the other way to recognize a chamfer, by the way, is most CAD software, when you create a chamfer, it actually keeps that data, right? So there's a lot more information in the CAD file than just the locations of the points. And so most CAM software can read the inherent information, the metadata of the, it was part of the metaverse, huh? We can draw from the force of the metaverse, and often it'll be a chamfer because it's been identified as a chamfer by the person who made the file. So that's the other way to identify it. So does it fit? And likewise, in the CAD software, when you create the solid model, you can specify material properties, right? You can say what material you want. Not all designers do that. Lazy ones especially don't. But you could know that you always cut parts out of aluminum. You could know that you always cut parts out of steel and what grade of steel it is, right? So with your database that has the list of available tools, it's also going to include trying to avoid using my hand to erase the board, looking for the eraser that was in my hand. So cutting data. So our list that tells us what the tool is also going to tell us the cutting data for the tool, right? It's stupid to keep those things in different locations. So with this tool, with this material, use this feed, speed. All right, so we've ID'd the features, we've ID'd the tooling. The tooling has with it the cutting data, the stuff that tells us. From here, then we decide where to put the tool, right? Then, so if we step back just a little, what time is it? 27. What's the schedule say we're doing right now? Oh, hey, I guess that's what we're doing. Sort of. Oh, no. No, I totally missed that. All right. I'm going to keep going. I just wanted to see what I wasn't doing. Right? If I forget to do something because I forgot to do it, that's bad. If I skip something because I decided to do something else instead, that's good, right? Maybe. Does it fit? And then what are the steps to go from point A to, or where does the tool have to go to physically turn the stock material into the part? So this is at the close in detail, right? If we take a step back, because we're not gonna use Microsoft Excel to create the, I mean, you could if you want to, I suppose. But if we're not going to use Microsoft Excel to create the toolpath, if we're not going to write a script that creates all of the code by doing the math ourselves, because if we did that, what would we be doing is creating CAM software, right? We already have CAM software. So let's use some CAM software that we already have. That sound good? So we take the step out. So once we've identified features, we will have identified things like chamfers, holes, pockets, contours around the edge, faces that we're going to face off, islands that we're going to leave behind when we do the facing to leave the island on your part, somewhere over here. So once we've identified those features, then if it's this kind of feature, use this kind of operation. And you guys all had that down, right? You had the list of operations that you would perform. So then you're going to look up to make this feature with this tool. This is the kind of operation that we would use. And then those operations are all going to have things like clearance planes. Where's the clearance plane in CNC? Anybody? It often helps you avoid crashing. So it's the point where you rapid to, or the height that you rapid to, because it's a plane, right? So it's the height that you rapid to before you start feed motion. And so typically we'd like to use the rapid movements anytime we're not intending to cut material. So we're just moving the tool from one place to another place in the machine tool. We'd like to use rapid motion, right? So we've got a clearance plane. We've got an entry mode and an exit mode for most programs, right? Most things. So if it'll have a way, maybe it'll come in on a radius. So we're doing a contour. We could go or we could go right? So we could come in smoothly on a radius, or we could just jam the tool over there and go. And at the end, remind me to tell you why I laughed about the texture on the fillet, by the way. Nothing. I don't see it here. Often, if you look at the side of a part, oh, no, I programmed all these parts. Never mind. If you look at the side of a part, you'll see a mark that shows that they jammed the tool over and then they went and did their contour. And if you don't see that mark, they probably came in on a radius. And then they exited on a radius that started just after the point where they came in. And then the two surfaces sort of blend together and you don't see the part where the tool slammed over into it. It only matters if the customer cares. It doesn't sound good either. Get that, wow, right? You like it nice, steady. You want it to be like the music you play when you're meditating. You don't want it to be jarring and upsetting. So not, yeah. So it should, the tool paths should have a sort of a Zen feature to them. You're gonna select the type of operation to use. The Esprit has built into it the ability to create these macros. You can actually, I think this, unless they've changed it since the latest version, but I don't think so. You can even you can do repetitive steps that you do often, and you can record a macro. You can say, record, and then go do some steps. And then say, stop recording. And then take another file and say, apply that macro. and it will apply all those steps to it. And so those could be steps like selecting the faces and creating features on them, things like that. So it's got that. It's also got a level where you can use any programming language that will let you program in the Windows API. So any Microsoft API programming language. So, and C, C++, all those, I think Java even, probably. Any of these programming languages you can use to access the Esprit API. And you could actually write your own complete own user interface, so that the person doing the programming never even opens Esprit, never sees that it's Esprit that you're using, but they literally, you can drag files into a folder, click a button, and have it apply all of these processes that you've automated here to all of the files in that folder, and put NC code, right? Because it's the NC code that we send to the machine tools. Put NC code in that folder, in another folder, just like that. Just drag, well, it depends how complicated the part is. You may have to slow down while you snap your fingers. You may have to drink some coffee. While you do it. But it's not as bad. Used to be you had to go make a pot of coffee. You couldn't just take a sip of coffee. Computers are faster now. I wanted to talk about group project discussion and get some quick group updates. We're a little bit behind group project discussion. How's the group project going? There was some people asked, could we get the feedback from the class back to you guys? Yes. We figured out a plan, right? When are we going to do that?
It's all published.
It's there. Go to the Canvas page and go to discussions.
Yep.
Canvas discussions. Look on the discussion for your group number, and there's an Excel file. Is that it? Is it Excel? And you separated out all the other information, just left the comments?
Yeah, it's just your question.
Just question and comment. Okay, good. I mean, I suppose everybody that did it should get the same grade, but somebody that was paying attention would also know the names of the people that did it, and then they'd know who was not getting the grade. No, that's not cool. I don't know. When I was a kid, it used to be cool. You had to go, like, at WPI, so I guess an adult kid, right? I'm still an adult kid. But, like, you'd taken a test. Do you still do tests on paper? I don't like tests on paper because then I have to grade them. I don't always have a Hayden. But you do your test on paper. The teacher would write 65 at the top of the test in big red letters, and then leave it in a box outside his door. And if you wanted your test back, you had to go pick it up from a box outside the professor's door where your name and your grade were right on the front, and anybody else going through the box could look at it. Was that good or bad? There's some peer pressure. I'm not certain all peer pressure is bad. If peer pressure makes you do something good, right? So I had a friend that told me about this 75 hard challenge that he did. And he did this challenge and he said he lost a lot of weight. And at the instant of hearing it, I said, I'm going to do that. I'm going to start tomorrow. That was back in November. Since November, I've lost 30 pounds. So not all peer pressure is bad. But I think I'd get fired if I did that today. Like if I made you come to my office, like if I made you come to my office to get your feedback in the first place, they'd probably get mad at me. But anyways, so you kids have it so easy. I don't know about that. You have it different. I don't know if it's easier or harder, but it's different. We had to walk to school both ways uphill in the snow. What I want to do is quickly check in with all the groups Just to see, are you guys on track? Do you need anything from us? What can we do to help you be good for Thursday? I had wanted to go over the template for the first slide that I want you guys to all use for your first slide. I had wanted to go over that at this point in the class, but I had also intended to create it at the point in the class where you guys were breaking into your groups. And instead we talked about getting you the feedback and I didn't create it. So I will create, now I'll make him create it now. So we will have a meeting at the end of this session and then one of the two of us will create it and we'll put it up there so you can download it. And again, that's just a quick, it's just a quick, this is what we did this week. This is what we're going to do next week. This is where we're having a problem, you know, so it should be pretty simple. I actually stole it. My wife works for Johnson & Johnson and she has a daily meeting with her group and each person in the group is assigned a day and they have to have one of these slides to go through with the entire group and the boss for each project that they're the head of. And I saw her doing her morning meeting because she works from home now because nobody goes to work anymore. And I said, hey, that's really cool. And so that was like 2 weeks ago. So I decided we'd work it into this class. Group project. All right. So group one is not here. So they can tell you in the chat if they need any help and if they're on track. Group 2, you guys are here, right? Group 2, how you doing? You on track? Do you need any help?
Yeah, I'm probably I gotta look at my availability and make an appointment with you or James to go over the military machine.
Okay, if it's with James, make it soon because Friday is his last day.
Is he leaving?
Yes, he got a new job. But I actually knew how to use that machine before he did. So we could probably figure it out. Okay. I'm just saying, if it's with James, do it soon. Hayden, have you used the mill turn? No.
No.
No. Okay. We're gonna stick you on the EDM people. And there's an EDM meeting. Is that today or tomorrow?
Tomorrow. I'll start at like 11, and then I assume some people have classes at 11, so just everyone wants to learn. I'll be there until like 2.
All right. So you guys are just gonna meet to go over mill turn stuff and capabilities so that you can figure out how to program the parts you need to make.
Yeah. And
Yeah.
we're also presenting a slide on it to teach everybody else.
Right. Okay. So we'll go into depth. Okay. That's group 2. Group 3 is over here. You guys are good.
Yeah, I'm good.
You're good. You're on track. There was a question about where to get materials because I told you guys to laser cut stuff. Yeah. Go to the Foisey, the building formerly known as Foisey. They have stuff there. And for expensive materials for your machining projects, we'll figure out how to get that stuff. But for a sheet of 1/4-inch plywood, you didn't have to buy a book for this class. So I would say figure that out. Group 4, that was 3, right? Group 4. You guys think you're pretty good?
Yeah,
Trying to remember what's group 4 doing.
we're gonna do the mill turn for the rotors.
Oh yeah. You guys have a complicated part. What was the task I gave you for this week?
Meet with you.
I gave you another task to have something prepared for Thursday, didn't I? I did. It was the first task was meet with me and see if the stock material I had for you was going to work.
Yep.
The second task was to have figured out how you were going to take that stock material and make it into the shape you want. Right? And so, because you're going to use a 3D freeform milling operation. So see if you can get some, so at least like an Esprit file that's got your part in it, that's got your solid in it. So your stock material, your solid model for the part, and start trying to get tool paths that make the part the shape you want. Could you guys had the part with the boss on top, right? Did you bring it up here? I laughed when you talked about putting the marks on the, let's see if I can get the camera here. putting the marks on the fillet here. I laughed about that here, so you guys can all see what I'm talking about. So at the fillet on the top of that boss, they put in an operation to make those marks. So those marks are caused by the process that made that part, not a feature in the solid model. And the way we made that fillet, right? So the fillet is a shape like this. And so the way we made that fillet was to take a ball end mill and to feed it around like that. And then index down the part a little bit and feed it around like that. And actually, I guess we were going back and forth probably. So we were going like this as we moved down that part to make that shape. And so the individual little lines you see, the marks, are indicating the step over between one pass and the next pass. And so if I wanted to make those marks go away, I would do a lot more passes. I would take smaller step overs. And I could actually, to within the human eyesight, I could make that feature and have it be shiny, be like mirror shiny, using this process. It would take a long time. So the person who made that, I have no idea who made that particular one. This was a teaching part for ME1800 PLAs one term. The person who made that particular part had a pretty good step over because they were in a hurry. I think we did a contest to see who could go the fastest from the solid model to the finished part. And so they maybe have been trying to push the feed rates. Since I didn't have a tolerance on surface finish for that feature, I guess it was within spec. All right, so last group, right? Group 5?
Yep.
Yeah.
We're
Hey.
working on tolerance and some stuff related to some internal pointers.
Okay.
And also getting started on practicing with the simplest.
Okay, and you guys are going to meet tomorrow to go over EDM?
Yes.
Okay.
No.
I'll add that in a little bit more. Super
Okay.
It's not like
What's group 1 got for us?
they didn't have any specific questions, so.
That user that I blocked came back.
Yeah, I saw that.
So same username, but like from a different place, obviously. I blocked them again. What a great username. Love face XYZ online strips without clothing is the username. They were posting a comment. We deleted the comments. You reported them too?
Yeah.
Go ahead.
I guess I'll try and meet with you then this week.
Yeah, you go ahead and meet with me.
Discuss material for the chess piece group.
Yep.
One is
I ordered material for your group on Friday, assuming you didn't change the size that you need, brass and aluminum.
lovely. Thank you.
Because we were placing a material order and I just added that to the order. So you can thank the ME department for the materials for your chess set because I didn't tell them that's what it was for. I just ordered it. Oh, shit. Live on the internet. That's okay. I'm certain they don't watch my YouTube channel. And hey, if they watched this video all the way to this point, thank you. Hey, they posted again. Look at that. Block user. They don't get the hint that they're being blocked. I don't know. I'm feeling a little excited because it's the first time I've ever had to block a user for outrageous comments on one of my videos. I think that moves me to a new level of YouTuber now, right?
I know a way to fix it.
You do?
We end class.
I'm done. Unless you guys have something else. I left that last 5 minutes as TBD. So
We could start watching Office Space.
we could, but it would be against the law for me to show it live right now on YouTube because I don't own the copyright for airing it in that sense. But I'm sure for like $2.99 you could buy it on YouTube. And I do own the DVD. We could do a private airing and just not tell anyone, because that would also violate the FBI license. Probably the FBI guys would swoop in now that I've said it online. All right. It would be more viewers. Yeah. Oh, they would be violating the copyright at the moment they came in to arrest us, wouldn't they?
Then you could arrest them.
Citizens arrest.